Hey everybody, I'm going to explain how to do number 6.66 from the end of the chapter problems. I'm recording this from home, so if you hear some cartoons in the background, that's my family watching TV. Ever since I started teaching this class, this particular question has given students a lot of problems as they're trying to figure out how to even answer it. Basically, the only way to do this is, for example, in letter A, write down all of the possible combinations where n equals 2 and the ms value equals -1/2. So when n equals 2, you have two possible values for L, 0 and 1. And when L equals 0, then you have the 1 ml value. And then when L equals 1, you have three possible ml values, -1, +1, and 0. And then for each one of those, you have to say that the ms value is -1/2. So if you look at the combinations where n equals 2 and ms equals -1/2, there are 4 of them. Now let's do the same thing, but for part B, where n equals 5 and L has to be 3. So we're in the fifth energy level, and we're specifically looking at the f orbital. In the fifth energy level, we have all 4 orbital types, but in part B, it narrows it down to specifically the f orbital. So n equals 5, L equals 3. So the possible ml values are -3, -2, -1, 0, +1, +2, and +3, or 7 options. And then each one of those ml values could have up to 2 possible electrons in them. So there's +1/2, -1/2 for all 7 of them. When you aggregate all these together, you have 14 possible electrons that share n equals 5 and L equals 3. So let's tackle part C. Just like we did before, we know that the energy level has to be 4 and the L value has to be 3. Well, the L value equals 3, once again, is the f orbital. So this is going to look a lot like part B. But where this one is a little bit different is that now I give you specifically the ml value has to be -3. So we've zeroed in on a specific energy level, a specific subshell, and a specific orbital. And only 2 electrons can be in an orbital, +1/2 and -1/2. So that is why the answer here for part C is only 2 electrons can share these 3 quantum numbers. Let's finish this off with part D. We're in the fourth energy level. L equals 0, so that's an s orbital. And the ml value is 0 as well. So that checks out. Just like before, when you get down to a specific ml value or specific orbital, we know that only 2 electrons can fit in any one orbital. In this case, the ml is 0, but still the ms is either +1/2 or -1/2. So once again, in part D, only 2 different electrons could share these 3 quantum numbers. I recommend in the future, if you ever encounter a question like this, use the information provided and list out all the possible combinations. And only then will you be able to identify how many electrons could satisfy these qualifying statements or these qualifying quantum numbers. That is the only way that I can think of in order to do this. Write it out, just like I did, and count how many electrons satisfy. Well, that takes care of this little video tutorial on how to do number 66 in chapter 6. Thanks for watching.